Hi, my name is Caroline Fieran, and this is my Lab 1 presentation. In this presentation, I will be discussing the purpose of and how I performed a real-life experiment of charge tapes, how I then created a computer model of the system using GlowScript, and finally how I compared and analyzed the experimental and computational models. The purpose of this lab is to determine the amount of excess charge on a charged piece of tape and to further understand how much charge can be transferred to an object through interactions like rubbing or touching. The goals and fundamental principles of this lab are to use Coulomb's law to calculate electric force and Newton's second law to calculate gravitational force using the equation shown below, additionally comparing the electric force and the gravitational force to calculate the electric charge of the tape. The main physics concepts used in this lab are Coulomb's law and Newton's second law. It's also important to understand that neutral objects can receive charges even though a charge itself is a conserved quantity. To preview the results, I found that the charged tape is positively charged because it's attracted to a negatively charged pin. The charge of the tape is 1.31 times 10 to the negative 8 coulombs. Further, because both of the charged tapes have the same charge, they will repel each other. I also realized that top tape, tape B, experiences a gravitational force that will counteract the electric force exerted by the bottom tape, tape A, hence the net force equation equaling 0 as shown below. In this lab, the system is tape B and its surroundings are tape A and any other objects used to support the charged tape. In this setup shown below, I first created a charged tape, tape B, by layering two pieces of tape onto each other and pulling the top tape off in a quick motion. Then I suspended tape B across two neutrally charged books for support. I then created a second piece of charged tape, tape A, and held tape A near tape B to observe the suspended tape float upwards. Then I measured and recorded the distance that tape B moved. The materials used are clear tape, a ruler, and neutrally charged items such as textbooks to help support the charged tape. The length and width of tape B are 0.2 meters and 0.019 meters respectively. Using the fact that tape has a density of 1 gram per meter, the mass of tape B is calculated to be 0.0002 kilograms, and the distance recorded between tape A and tape B, at which tape B begins to float upwards, is 0.28 meters. I then used the mass of the tape to find the magnitude of the gravitational force of tape B to be 0.00196 newtons, and then the net force equation from earlier to find the magnitude of the electric force on tape B due to tape A to also be 0.00196 newtons. Finally, by rearranging the force due to the electric field equation, I found the charge of tape B to be 1.31 times 10 to the negative 8 coulombs. To find the number of electrons on tape B, I divided the charge of the tape by the magnitude of an electron charge. Therefore, 8.17 times 10 to the negative 19 electrons deficient are found on tape B, meaning that it is positively charged. I then found the total number of atoms on tape B by dividing the area of tape B by the approximate area of an atom, giving a total of 3.8 times 10 to the 17 atoms. Then I calculated the ratio of electrons to atoms and found there to be 2.15 times 10 to the negative 7 electrons deficient to the number of atoms on tape B. I made the following assumptions when creating my GlowScript model. First, I ignored air resistance on tape B as it moved upwards. I also treated each tape as a point charge as if all of its charge were concentrated at the center, and also assumed each charged tape to have approximately the same amount of charge. Finally, in order to find the number of atoms on the charged tape, I assumed the atoms to be 2D squares. To initialize my code, I created variables for the different constants I needed. I defined two spheres as objects, one for the particle and one for the tape system, where tape A is the particle and tape B is the system. I then calculated the gravitational force in tape B, as well as the electric force, which I defined to be the opposite of the gravitational force vector. I then defined arrows to create a free body diagram that shows the gravitational and electric force on tape B. Next, I found the position vector between the two spheres, as well as their magnitude and the unit vector. Using the gravitational force, I calculated the charge on tape B, number of electrons on tape B, as well as the number of atoms on tape B, and finally finding the ratio of the number of deficient electrons to the number of atoms on tape B. This is the visual that my program created with the electric force depicted in the green arrow and the gravitational force in the blue arrow. Also included are the printed computational statements. When comparing the models, one can see that the results are the same, which supports the success of my GlowScript code. The main difference between the models was the accuracy of the computational model being greater than the experimental model. To improve future experiments, I could have created an isolated experiment environment to make sure that the charged tape didn't come into contact with other objects. The computational model could also have been improved by accounting for air resistance and including the entire length of the tape instead of the tape as just a point charge. If protons and electrons switch charges, the observations between the charged tapes would not change, as the charged tapes would still repel each other since they have like charges. However, if the charged tape were to interact with a negatively charged pin, the tape would repel the pin due to the fact that protons now have a negative charge. It's important to handle charged tapes as little as possible because when charged tapes come into contact with hands or other objects, their given charge will be distributed between the two objects and the effects from their charge will no longer be observed. In conclusion, this lab demonstrated that charges can be given to neutral objects and also applied Newton's second law and Coulomb's law to calculate electric charge. This lab was a study of charged objects, but there are many different scenarios of interactions that can also be analyzed with computer models. Thank you.